In this video, I'm going to be going over some key definitions to help you to better understand what's happening with neurons and muscle cells and conducting of action potentials. These key terms are voltage, current, and resistance. When you look at voltage, this is a measure of potential energy generated by separated charges. So when you look at a cell membrane, right along that membrane, we're going to see that there's a difference in charge. Inside of that cell membrane is relatively negative compared to the outside of the membrane, which is relatively positive. Most of the cell is going to be neutral. It's going to have just many positive and negative charges. And outside the cell is going to be neutral. It's only along this membrane do we find this change in voltage. We measure the change in voltage with a voltmeter. The units are in volts, but for neurons and muscle cells or cells of the body, you're going to measure in millivolts. A very small amount of voltage difference. Voltage is measured between 2 points and is called the potential difference between the 2 points. So if you take a voltmeter, for example, and I have the two probes here outside of the cell, it's going to read 0 millivolts. And if I put the two probes inside of the cell, it will read 0 millivolts. But if I put one outside the cell and one inside the cell, that's going to measure a difference, a potential difference between the 2 points. And that will be a negative charge, a relatively negative charge. For example, neurons is going to be around minus 70 millivolts. The greater the difference in charge between 2 points, the higher the voltage. So looking at this cell membrane, I have 3 positive charges here, 3 relatively negative charges here. That has a potential difference, but it's going to be lower amount of voltage than if I take this cell membrane here, which has a lot more positive charges relative to the negative charges inside that cell. So this is going to have a higher voltage difference. And we talk about potential difference or potential energy. This is really important to understand because what the cell is going to do is it's going to use this difference in charges to send action potentials or impulses along a neuron and a muscle cell. In looking at potential energy, this is energy of position. Potential energy is the energy that an object has because of its position relative to other objects. And it has the potential to be converted into other forms of energy, like kinetic energy. So this difference in charge between one side of the cell to the other side of the cell represents potential energy. Much like, for example, when you look at a dam here, here's Shasta Dam. This water behind the dam has potential energy. And when it's allowed to flow through these pipes here, it's going to turn the turbines in this plant to make electricity. So it's taking the potential energy of water to convert it to kinetic energy as it flows down those pipes and convert it to electricity. A dam has a lot of potential energy, say compared to this beaver dam right here, which has water built up on this side, so there's potential energy, but not a lot of potential energy. This is representing what's happening between these 3 membranes. This has a little bit of a charge difference, a little bit of potential energy, a little bit of voltage difference. This one has a lot more voltage difference. And what is the cell going to do with this energy? It's going to allow ions to flow through. So for example, we're going to see there's a lot more sodium outside the cell than inside the cell, and a lot more potassium inside the cell than outside the cell. And when these are allowed to flow through, then you get action potentials. Sodium's going to flow down its concentration gradient into the cell, and potassium is going to flow down its concentration gradient out of the cell to give you an action potential. My gosh, the cells use this potential energy to send action potentials, impulses along neuron membranes. Second term you need to know, current. This is the flow of electrical charge from one point to another. In electrical wires, we talk about electrons. In the body, electrical currents reflect the flow of ions rather than free electrons across a cellular membrane. As these ions flow through, here we have sodium flowing in and the potassium flowing out, that's going to give us a change in voltage and a flow of current along these membranes. But it's ions, sodium and potassium, which we've been talking about so far. Resistance is the hindrance to charge flow provided by substances through which a current must pass. Where we see this playing a major role is the phospholipid bilayer. There's resistance to the flow of these ions due to this phospholipid bilayer. And so these ions have to flow through channels, which are in this phospholipid bilayer, so they can flow into the cell and out of the cell And the cell is going to control the flowing of these at the channels. It's going to open them and close those channels so that it sends action potentials when it's needed. All right, so let's test our understanding. Pause the video, answer the following questions. Here are the answers. And this concludes the video. Let me know if you have any questions.